That was when I did negative 7 plus root 7. And 3.215 seconds. Now, because I know that this is a parabola that is opening down, it's going to start out, well, I'm not positive, but it's going to start out like going like this, right? This is the velocity curve. Okay. All that means is that the slope of that curve is positive, which means acceleration is going to be positive for some point in time, and then it's going to switch to negative. This original curve, negative t cubed plus 7t, if I wanted to know what was actually going on with the curve, I should graph the velocity, because when the velocity is a positive number, that means that the particle is moving to the right. When the velocity is negative, it's moving to the left, correct? And we already know the two spots that it rests right here. And this is where I was saying, because this isn't something we know how to graph in our heads, let's take a look at the graph of the velocity. Okay? So this is the velocity curve. I know you can do this curve. We've done that in pre-calculus, that we've looked at that curve and found when is it increasing, decreasing, and so on. I want to look at the velocity and see if we can sort out what that means. Okay, so you guys see that, right? I hope. This is the 1.451, and this is the 3.215. Okay, remember guys, this curve represents the slope of the original, or the position of the original function, okay? So, if the velocity represents that, since this is over here, right now, that means the velocity is a negative number. Tell me what the particle's doing from 0 to 1.451 seconds. If the velocity is a negative number. Okay, very good. And I'm going to just put this from 0 to 1.451. You guys all okay with that interval notation? We already talked about how it stops at 4.51, right? So it's at rest, and then what happens? Do you see the velocity is a positive number here? That means the particle is moving in a positive direction. So particle is moving to the right. And that's from 1.451 to 3.215, where the velocity is then at rest again. And what happens the remainder of the time? Yeah. And I'm going to put from 3.215 to infinity. Now, I understand that this isn't going to go on forever, but the function never told me where it stopped or at what time it stopped. It just told me that it was t is greater than or equal to 0. So, until I tell you it stops, that's what we would write. Nope, is our x value. So, I mean, as time continues to go on to infinity, that particle is going to be moving to the left the entire time. It would be the x of the end behavior, yeah. Okay, we did this, correct? Let's do 2 together. Now, once again, what am I looking at? Because this is a different question. What am I looking at right now? What's the label? The velocity, okay. So, this is different than looking at a position graph. When does the particle reverse direction? When the velocity graph is switching from a negative to positive or positive to negative, or when it's zero, correct? Where are the times when the particle reverses direction then? We're looking at the velocity graph. So I'm trying to find where is the velocity equal to zero. Brett, you said what? 1 second, and can we say like 4 point something? 4.2 seconds? I know it's not perfect, but alright. So how about when is the particle moving at a constant speed? Nice.
4.7 to 6.
I'll say 5 to 6 seconds. When is the particle moving at its greatest speed?
2 or 5 to 6? No.
When does it reach its greatest speed? I'm looking for either the highest or the lowest part of the graph.
3.
Do you see that this would actually be a speed of 3, right? Because it just means that it's going in the left direction. So the particle is moving at the greatest speed when time equals 3 seconds. Okay. Graph the acceleration we're defined. So the acceleration is the derivative of velocity, right? So we're going to do this in a similar way that we did the one at the beginning of class. We are going to be finding the slope of the velocity curve and graphing it. So the velocity curve has, it looks like a slope here, another slope here, here, and here. 4 different slopes. Would you find them for me, please? Did you get a slope of -2 right here?
Yeah.
Okay, so then I just plot it like this. Remember, I use open circles because anytime there's a corner that it's not defined. Okay, what is the slope from 2 to 3? Does it look like? Right here. -1, so I'm going to make my horizontal line at -1. Then, how about from 3 to 5? Is it like 5 over 2? So 2.5? So there's 2.5. And then what about 5 to 6? Slope of 0, so I do that. Okay. Alrighty.